Hello, I'm back with some more tips on how you can improve the quality of your ironed surfaces. This is Mad Matt Malloy. Keep watching. So, during my last video on how to improve the quality of ironed surfaces, I'll put a link to that video up here in the top right hand corner if you haven't seen it. I mentioned that one of the things you could do is increase the sparse infill density that we can see here. Now, I didn't actually do that within that video. I took a different approach where I increased the number of top shell layers and increased or put a value in for the top shell thickness. Now, I got a message from Sussex Spaniel asking me if I actually had done any tests with the sparse infill density, which I have to admit I haven't. So I thought I'd do a video which would look and see how increasing the infill density would affect the cycle time compared to the method that I used. Cycle time? I sound as if I'm at work here. What the comparison of the print times would be between changing the sparse infill density value, increasing it, and running it with the 5 top shell layers with a top shell thickness of 0.8, which is what I did in the previous video. Now, Sussex Spaniel also mentioned that I could look at changing adding modifiers to the model to increase the quality in specific areas. And again, I'm going to show you how you can go about doing that, and again we'll have a look and see how the cycle time of that compares to the number of top shell layers. So, to start off, here we have the model that I'm going to be using as the example for this. I hope you're not getting dizzy watching me whiz that around. And what I want to do to start off with is just slice this. If you remember in the previous video, I did adaptive layers to give us final layers where we had the finest detail. So I've done that on this, and now I'm going to slice it, and this will give me a time and an amount of material that we will be using to produce this in the manner that was discussed in my last video. So we can see here we've got 42.99 grams of material, and this is going to take 1 hour and 17 minutes. Okay, so I can now go back to prepare, and what I want to do now quite simply is I want to look at increasing this infill density. Now, I consider 25% to be quite dense, and I'm sure that would give me a decent, a much closer knitted grid that would give me less bridging and would mean that I'd need less shell layers on the top. So before I do that, let me just go to preview on this, and let me just give you an example. So this is the spacing that I have at 15%. If the first thing I do is go in here, change this to 25%, you'll notice it will regenerate if I press slice. So we'll slice this, and then we'll look and see, and we can see that that gap there has improved considerably. And what I'm going to do is I'm going to take that down to 3 layers, and I'm going to get rid of the top shell thickness. Same for the bottom layer. So there we go. These are the default settings I had for top shell thickness and top shell layers that came with the slicer, and I've just increased the sparse infill density here. So I'm going to slice this now, and we will look at the results. And we can see here I have 1 hour and 21 minutes, and I am using 48.04 grams. All very precise, this isn't it, 0.04 grams. So, looking at those values, I have 42.99 grams for the method that I used previously, 43 grams, and I've got 48 grams by reducing the number of top shell layers down and increasing the infill density. So from this I would conclude, well, I was happy with what I got from increasing the top shell thickness, the quality that I got there. I can't really see why I would increase the infill density in a bid to get the same type of result if that means that I use an extra 5 grams of material, and it would take an extra, if you remember it was 1 hour 17 minutes, if it would take an extra 4 minutes. There's just no logic in my mind for me to do it this way. So on the first thing I'm looking at here, I'm happy that what I did, increasing the top shell layers quantity, increasing that to 5 and the top shell thickness to 0.8, I am happy that that is a better means of improving the I'm forgetting the title of this video now, of improving the quality of the iron surfaces. Now, where would the infill be better? I guess the infill could possibly be better if you had a much thinner component, because imagine on this we've got quite a bit of thickness here where it's printing at the larger infill density, which means we're using more material inside here, and using that more material over a larger height means that it's going to obviously take longer, which is what the results show. If this was thin, say as thin as this bottom section here, I think because we haven't got so many layers that we'd be doing at the greater infill density, you'd probably find something like that. It might actually work out more effective to change this infill density rather than messing about with the top shell layers. You could, if you wanted, go in and do a couple of slices like I've just done. So you could go in, slice it with the greater shell layers, slice it with the greater infill density, and see which one comes out quicker, which one comes out cheaper, and make a decision based on that. Personally, the models I produce tend to have the height in it, like this one. So in a comparison between these two types, or these two methods, I would go for greater shell layer height and a value in there for the top shell thickness. So as it is at the minute, I'm taking you back to 15. I'm getting rid of you there. I'm getting rid of you there. 5 and 4. These are the settings that I'm going for at this point. So here we have the model, and I now need to look at adding modifiers to this model to help me improve the quality of the iron surfaces. And to do that, I'm going to split this into 3 different elements. So a modifier itself, a modifier is anything that you can add or do to this model which will modify it. So you've brought in your STL or your 3MF file. If you want to add a cylinder, add a cube, you want to cut it up, you want to add pegs and dowel holes, they're all classed as modifiers. And what I want to do is I want to use the cut command here, and I'm going to break this into 3 different sections, and I'll explain the sections now. The first section is this surface and below. The second section is just above this surface and up to this surface here, or just below this surface here. And the reason for that is up to this surface, this is the first ironed surface that I want to be produced to a good quality. Second portion between there and up to this surface, I'm not so fussed about iron surfaces. I've got a couple of little iron surfaces in there, but my gut's telling me I'm not going to have too much problem with these. Where I'm going to have the problem is these bigger surfaces at the top here, and I need them to have better quality ironing on them. So I'm going to take this model and I'm going to slice it into those 3 sections. I'm going to look square on the side of here first. So if you use Control and the number buttons, you can get different views of this model: above, below, sides, front, back. And if I do Control 3, I get that view across the front of it. I come up to the cut command, and we can see here that I have a cut plane. So again, you can see the cut plane there in the isometric view. If I go side on, I know that cut plane is on this blue line here, and what I want to do is I want to bring that down so it's just above this surface that I want good quality ironing on. Now, I've done this before, and I know that I need to go down -14 on that. And if we're looking here, we can see I'm just above that surface. So what I want to do, I want to slice it. And when I slice it, that'll leave me with 2 parts. It'll leave me with the bottom part here and the bit above it. I want to keep both those parts. If I wanted to just delete one of them and keep one, I could switch that off, and it would just give me one of the 2 elements here. And then the other one, place on cut. I'm doing that because I don't want the models to move, or the parts to move, after they've been sliced. If I switched one of them off, it would jump to another position on the bed. Now obviously with this, because I want to build it in the order that we can see here, I want to place it on the cut line. And finally, I want to do cut to parts. For some strange reason, I only find out that when I do cut to parts, that's the only time it'll leave it on the place on cut lines. I don't know whether it's a glitch within BambStudio or what, but if I break it into objects and don't have the cut to part selected, it'll actually take one of the parts and move it elsewhere. Anyway, enough of me waffling. Perform cut, and we can see here I have 2 sections, and we can see where the slit line is there. So top section, so 1, 2, 3, the top section I want just below this line. Now what I'm going to do with this top section is, just for the top section, I'm going to have the infill density greater. So I want a little bit of the height to allow me to get that increased infill density established before I start laying down the top layers. So if I again go to my cut command and move this up, if I start 10 mil up, oh that's too much, let's go down -1, in fact down -0.5. so you can see here I'm just below there, so I'm about 1.5 mil, a little bit more below that surface that I want ironing. So that'll give me probably about 8 layers to establish the that's at 0.2, about 8 layers to establish the support for the top before I put the ironed layer on. In fact, I'm a little bit nervous here. I'm going to go down another 0.5 mil just to be sure that I've got that infill pattern at the greater density fully established before I start laying the top layers down. Again, I do a perform cut, keep the bits, and we can see here I now have 3 pieces. It's asking me to repair the model. Let me just do that. So now I have it slit into 3 pieces, and as we've said, I'm going to go back to what the previous values were here. So 3 bottom layers, 3 top layers, no top shell thickness, and I'm going to have to start off with an infill density of 15%. Then what I want to do is I want to look at the individual objects that we have on the board here. So if you come across here alongside process, this is global. It's selected to global, which means that all these settings will apply to everything on the board. However, if I go to objects, we can see that it's broken down to different items upon the build plate. Did I call that board before? Build plate. And we can see I've got the bottom one and the top one, which I want to do the modifications to. So what I'm going to do here is I'm going to go into quality. It's got me thinking, is it quality or is it strength? It's strength. I'm going to go into here and I'm going to increase the sparse infill density to 25% in this section. So I do that, and we can see here I've got a little lock which shows that I've modified that top element there. Again, I'm going to come to the bottom element. I'm going to go to the same place here and I'm going to increase that infill density to 25% as well. I've done that, click, and we can see that the top layer and the bottom layer have been modified with the larger infill density. I'm going to come back to the global setting here, and I'm just going to select the part, and we can see when I select the part, the whole thing is selected. So that means that it's treating this as a single part. It's treating it as an assembly, which is what I want. So I'm going to slice this, and then I'm going to come down and scroll through the layers so that we can see how the infill density changes. So here I am in the middle, I've got me 15%. As I come down to the bottom here, you can see on the bottom bit it's finer. Then as I move up, we start to construct, around about this place, is it? Yes, see there. We start to construct the denser infill pattern on there to support the top layers that are going to be ironed. So here goes. Let's have a look at this. You can see here I have the values. So filament 40.73 grams. Print time 1 hour 9 minutes. Sorry, 1 hour 14 minutes. So if we compare that to what was, I'm giving you the results now, what was the best method of getting iron surfaces by adjusting the top shell layers, I am now using 40.73 grams of material compared to 42.99 grams of material. So we're looking at about 2.3 grams. Oh, I'll be a millionaire saving 2.3 grams on every model. And the time, which is an interesting one, this one is taking 1 hour and 14 minutes, and on the previous best it was 1 hour and 17 minutes. So there we go, that's pretty conclusive. I mean, albeit these seem small numbers, it does highlight which is the most effective way to do these changes. You could actually break things down even more, couldn't you? You could break it down for this layer, and then again break it down just below here for these layers, and again another break, so you could put lots of cuts in there. Now, because I'm a lazy git, well, am I going to get censored for saying git on YouTube? Because I'm a lazy git, I would probably still just stick with increasing the top shell layers, and then I don't have to go through the rigmarole of adding cuts and everything into here. But if you've got a big model that fills the whole plate and is pretty high, I think these minuscule values that we see in here could become quite significant. In those instances, it might be worth doing that. It's good to know different options, is what I think. And the conclusion I've got from this is that this appears to be the most effective way of producing a good quality part with good quality ironed surfaces. All that's left for me to do now is to press print, and we'll have a look at it once it's complete. So, the print has completed, and now we can have a look at the actual model. Photo coming. Here we are. Now, if we look at this, we can see the surfaces that have been ironed. So we're looking at this bottom surface here. We're also looking at these top surfaces. I would say this surface, these two surfaces, and that surface look pretty good. The surface at the bottom here isn't so good. We can still see lines there where it hasn't fully formed and hasn't been ironed fully. And again, if we come up to here, if you remember, we did adaptive layer on that, and these layers on the top here were thinner than your nominal 0.2 millimeter layer. And what you can see is the diamond shapes underneath, which is what the filament is bridging across as it applies the top three layers here. And because we have the ghosting on this face, this means that we are moving ever so slightly, we are undulating on that top surface and not getting something that is perfectly smooth. So I think it's safe to say that these results aren't perhaps as good as I was hoping for, and it kind of indicates to me that if you are going to do ironing, stick more layers on top. The more layers we can put on top, the more material we can put on top, the better that ironing is going to be. So if we come and have a look at the previous model, which I can see here, we can see here that the surfaces are a lot better, or do appear a lot better. So you remember on this one we have 5 layers. You can see there's a ever so slight discrepancy there on that top surface. Don't know what's caused that, but we can see the rest of the surface here around the top, this surface where we had the ghosting on the previous one, and the top layers here, they look exceptionally good. And this concludes to me that regardless of what I said in the last section about using modifiers to improve the ironing effect, I wouldn't do that in practice. When we actually look at the physical products here, we can see for certain that increasing the number of top layers prior to putting the ironing layer on, it gives us considerably better ironed surface finish. It gives us a lovely smooth finish on top. So now it's my turn to apologise. I've just made you sit through a 20-minute video to look at alternative methods of ironing in an advanced ironing video, only to conclude that what I showed you in the first place on that first video was in fact the best method. So if you want a refresher on what was said in that first video, or if you haven't watched it and you want to watch it now, click this link that you can see down here, and then you can go through the settings which are used to create the original and best ironed surface finish. This is Mad Mark Malloy signing out.